Hi, and welcome to this A-level maths lesson looking at differentiation from first principles. Now, differentiation from first principles used to be something that we just taught to help you understand where differentiation comes from. However, it has become more and more important in the A-level syllabus and actually has appeared in the last couple of years of papers across some of the exam boards. So it is worth just taking 10 minutes to go over. Now, you'll find differentiation from first principles is really formulaic. It follows the same pattern each time. There are 6 practice questions in the accompanying worksheet, and you will start to see as you go through that they always follow the same pattern. Now, in differentiation from first principles, we use the actual definition of differentiation, which explains where differentiation came from. Now, if you've forgotten this or your teacher glossed over this, don't worry, I'm going to explain it right now. So the gradient function or derivative of a curve can be written as f primed x is equal to, remember f primed x is the same as dy by dx, the limit as h tends to 0 of f of x plus h minus f of x all over h. Okay, and what this means is f of x plus h is small, h gets infinitesimally small. And so what it is we're taking a point on our curve, we're taking the next point along on our curve, and we are measuring the change in y over the distance, the change in x. And so as those points get closer and closer and closer, they converge on the derivative, the gradient at that specific point. And so we might get an exam question that asked us to prove from first principles the derivative of something. And we would use this formula. So we are going to prove today from first principles the derivative of 4x squared is 8x. Okay, we're going to use first principles to differentiate 4x squared. So f of x is 4x squared. I can say then that f primed of x is equal to the limit as h tends to 0 of f of x plus h, 4x plus h squared minus 4x squared all over h. Oh, that's meant to be a h. It's a very short h. There we go. I would then expand out the bracket. So I can say the limit as h tends to 0 of 4x squared plus 2xh plus h squared minus 4x squared all over h. Which I can then, if I clear myself some space, or can I move on to the next board? Yep. Which I can then say f primed of x is the limit as h tends to 0 of 4x squared plus 8xh plus 4h squared minus 4x squared all over h. The 4x squared take away 4x squared are going to disappear. So I get the limit as h tends to 0. Those are going to disappear. So I get 8xh plus 4h squared all over h. That becomes the limit as h tends to 0 of 8x plus 4h. Well, as h tends to 0, 4h is going to tend to 0, and so that becomes 8x. And you have just proven that the derivative of 4x squared is 8x from first principles. And that's it. that's how we prove how to differentiate things. That is differentiation from first principles. Now, their worksheet that accompanies this video shouldn't take you too long. It's got a few different functions in there. Please have an attempt. It's really good to practice this. It's one of those things where it's worth 4 to 5 marks if it comes up on the exam, but if it does come up, it's a really nice formulaic 4 or 5 marks. So go away and have a practice. If you have any questions or comments, pop them in the box below. But thank you guys for watching, and I will see you in the next video. Bye.